Well, I make that bang on 12 o'clock. So I hope you can hear me now, John. I've just taken myself off mute. Um, Welcome to part two of this webinar series, webcast series, whatever you want to call it, building cross-platform applications. And what I want to do today is really dive into a pretty demo-heavy presentation. And so we've got an hour kicking off now to 1 o'clock. I'd love it if you could ask questions, but the way I'd love you to ask questions, if possible, is to do so in the Q&A window on the left-hand, so what should be on the left-hand side of your screen, where I've popped something up about if you're having trouble with sound, how to find out about that, and if you know, see that John's put a note in there saying, asking whether I'd started yet, and I hadn't, and now I have. So welcome. For those of you I haven't met, my name's Andrew Coates, and for those of you I have met, my name's still Andrew Coates. I'm a developer evangelist, or now called officially a technical evangelist here at Microsoft in Australia. I've been a .NET developer for a bit over 10 years. Actually, that's how long I've been at Microsoft. I don't tell a lot of people this, but my native language is actually not .NET, it's Visual Foxborough. But I've been doing the .NET stuff for a while now. I'm particularly interested at the moment in mobile dev, and of course, if you're interested in mobile dev, you really have to be interested in cross-platform dev, because while our mobile offering is fantastic and it's a beautiful platform to write for and to build on, it's I have to admit it's not as widely accepted as some of the other platforms out there. So it makes a bunch of sense to build for all of them. Now, to do that, you need a strategy that means that you don't have to build individually for every platform. We talked about this last month, and there'll be a call back to the slides at some stage, either in the follow-up email to this session, or if I get around to it, we'll pop it in the notes as well. Sorry, in the messages window from the slides from last time. Unfortunately, we didn't get a recording of last time. That was my fault. I'm presenting from a brand new rig here, and I think we've sorted it out now because Esther's on and recording, which is awesome. So we should have a recording of this one, and if there's a huge demand, we might record the previous one as well, re-recorded somewhere. But let's get on to some things now. So last month we covered briefly what we covered last month was why would you do cross-platform development, and how would you approach it in a way that made sense to do to build this little code as possible. I'm just going to make it so we can. There we go. Excellent. As little code as possible, which particularly means have as much common code as possible across the platforms. And of course, there are a number of frameworks out there. We talked about some of the frameworks that are out there, and particularly interesting since last time we spoke was the introduction of first-class support for Cordova in Visual Studio. It was announced at TechEd. Now, I'm not covering any of that here. I still, but my personal opinion still, and this is a personal opinion rather than one that represents the company necessarily, is that things like Cordova are interesting, but you pay a penalty of being sort of neither a truly platform independent offering, nor a true native offering, and therefore you're kind of the worst of both worlds and perhaps not the best of either. Things like Cordova certainly have their place. The Web Application Toolkit certainly has its place. And building HTML5 certainly has its place, but we're particularly talking about building native code, and particularly talking about building native code with Xamarin rather than individually with Objective-C and Java and C#. So we're only talking about building with C#, and we're using the Xamarin tools. And particularly, I want to talk today about how you take those Xamarin tools and extend them with a great framework called MvvmCross. So I'd love some feedback about this session. I'll show this slide again at the end, but here are my details. If you want to get in touch with me, you can catch me on email or Twitter or on my blog or listen to our podcast. But I'd particularly love you to snap that QR code at some stage or click on the Coatsy feedback link down the bottom there. Give me a snapshot of what you thought about today's session, what you'd like to see done better, how you'd like things done differently, and so on, or things you liked. I also like that. So please feel free to do that. As I said, at the end, again, I'll show this slide, the feedback slide, but there's all the details. Perhaps if you want to take a screenshot right now, then you've got all that stuff. If you can't grab the notes, can't grab the slides. So I'll give everyone a moment or two to grab that. I really would appreciate that feedback. So last week we talked specifically about, last month we talked specifically about just using Xamarin, but we didn't talk all that much, if at all, about some of the framework ideas behind building a good cross-platform implementation. And I want to quickly, just for a single slide after this, touch on, a couple of slides potentially, I will touch on what an interesting approach to building native application is called MvvM. And we'll talk quickly about what that is. So MvvM can probably be summarized best with a bit of a diagram. So let's quickly, you start off with a model, and the model's the data. It doesn't have to be a database. It could be a web service. It could just be data classes. It could be some persistence through some file system. It doesn't really matter, but it basically says, here's what you want to store and retrieve. And these are the sorts of things you generally do CRUD operations on. They tend not to have any other capabilities, the models, than the ability to be stored and retrieved and updated. But that's at one end of your spectrum. This is the stuff that you're going to use to create a wonderful application. That's the model. At the other end, you have the wonderful application, which is surfacing all this data. I've chosen this wonderful application, the tick one. I quite like this because it's a great example of an MvvM application, by the way. If you want to have a look at it running on multiple platforms, it runs beautifully on this particular version of it, runs beautifully on Windows and Windows Phone. There are different views on the same view models with a bunch of common libraries in between. The bit that holds it all together is this thing in the middle, the view model. And the view model is what we're going to talk a lot about right now, and then I'll show you in action in a moment. The view model basically provides you with the ability to read and write to the models and display the information that's being read and written on the screen. Now, the view model has some interesting stuff in between. The view model abstracts away the structure of the model. So the view model may or may not represent the way may or may not have a structure that is the same as the way the model is. The model might have tables in a particular format. It might have joins done in a particular way. The view model doesn't have to do that at all. The view model, and I'll show you an example of that in a moment, actually, in the sample we're going to build. But the view model also provides some other functionality too. The view model takes stuff out of the model, represents it in a way that wants to be shown on a screen, and then puts it up into the view, or allows the view to display it on the screen in a way that makes sense for that particular device. Now, the neat thing about this is the view model can be common across the entire set of applications, and the view is the thing that you surface differently on the different devices. And so all of the functionality in the view model might do things like going and talking to the database, might do things like calling web services, might do things like reconfiguring the results coming back from a database call to be displayed on the screen. And all those things are common across all of the devices. The things that are different is how those things get displayed. So if you have a list of in this particular case, concepts, do you display them in some sort of group format with a vertical scrolling like you do on the Windows Phone here? Do you display them in a great big format with multiple groups that might include semantic zoom like you might on the Windows 8? All sorts of other options as well, like perhaps you're just exposing it as an API. But those sorts of things are a really interesting way of doing it. What we need to think about is some of the concepts that are inherent in MvvM. So the first thing is that we rely very heavily on the concept of being able to bind to properties of a view model. And we do that through an interface called iNotifyPropertyChange. And I'm just trying to mute a few people here. My apologies if I've muted you and you wanted to talk, but we were getting a bunch of feedback. iNotifyPropertyChange. Now, iNotifyPropertyChange basically allows the view model to raise an event whenever something changes in its properties. A view model is simply a class that basically says, I've got a bunch of properties I expose and some other things we'll talk about in a moment, but a bunch of properties I expose that the view can show on their screen, for want of a better term. So when something changes, I want it to change on the screen as well. And the way it does this is it says, I will implement this interface called iNotifyPropertyChange, and then the binding engine, which is built into the various the various platforms takes that information and acts on it whenever the event is fired. Now, it's a really, really powerful way of doing things because it means that as a developer, you only need to worry about changing stuff in the view model. You never need to have to change stuff in the view. You never have to explicitly bind things. You never have to explicitly update stuff that you change in the view because the binding takes care of that. And then you never have to explicitly go and poll for changes because the notify property change takes care of that. So that's very neat. And I'll show you a bunch of these things as we go through. I won't show you all of these things today. I think that we've got too many to show all in one day. But hopefully next time we'll do some more of this as well. But I will certainly cover notify property change. We'll also cover iCommand. Now, commands are really interesting too because commands allow you to specify things that need to happen based on the based on actions that might be taken in the view. So the view model might need to do stuff like go to a different place or send an update command to the back end or whatever it happens to be. Now, the last thing you want is for all of that code to be encoded behind in the view because then you have to write it every time. That stuff is common across all of the views, and so what you want is that code to be in the view model. And then you need a way of of the view firing that code in the view model, and you do that through the iCommand interface, which basically provides a way for the view to bind to essentially a method. What's happening behind the scenes is a method of the view model, and fire that stuff off. So, for example, we'll see this in a minute. We're going to build an application that works out that tracks that records where we are and what vehicle we're driving, and it sends that back up to a service. Now, the update of my location is something that should happen only when my location changes. Now, my device knows when my location changes, but the update should happen regardless of what device I'm using. And so the device needs to tell the view model, hey, my location's changed, and then the view model, for example, needs to send that information back to wherever that information has been stored through the model. And so the iCommand gives you an opportunity to do that. It's not necessarily an MvvM concept, but it's something that we use a fair bit in MvvM. Dependency injection is the idea that when you need to do something, a common kind of thing across multiple let's say multiple platforms, although it's not just a platform thing, when you need to do a common kind of thing, but you need to do it in a different way in different situations, what you can do is define an interface that says, when I do let's say, map my location thing, I'm going to have a map, I'm going to have a zoom, I'm going to have a drop pin, and those sort of things. And so I'll define those in an interface, and then at runtime, I'll use a dependency injection pattern to say, what concrete class do I have that implements that interface for this particular view or this particular platform? Mapping is a great example of this. There are a bunch of others as well, file IO, a number of other things that are platform specific. That gives us the opportunity in the view model to say, to write generic code which says, and defer getting the concrete object until we know at runtime what it's going to be, but knowing that concrete object will have certain properties and methods that we can access in the view model. And then the view model code can be common across all of the libraries, and have the implementation left to runtime for the view. We'll talk a little bit about platform independent code. This is something we do a lot of in MvvM. We want as much stuff as possible to be platform independent, and particularly things like internet access and those sorts of things can be used in a common set of C# libraries like the HTTP client library, which makes it very simple to go and do stuff with the back end of a system, and not have to write that every time in a bunch of different languages for a bunch of different views. We've talked a little bit about platform-specific code, but there are some things potentially that may only work on a particular platform, may only be relevant on a particular platform. And move that stuff into the platform-specific project. And then we'll talk a little bit about navigation. That'll probably be a topic for next time. I was going to see someone else is still making a little bit of background noise, and I'll see if I can find out who that is by across and muting. What's that one? Yeah, that sounds a bit better. So my apologies. It's one of the beauties of having a dial-in as well as a web client. It just does happen from time to time. So I guess enough talking. Let's hook in and have a look at a demo. What I'm going to do is switch across to Visual Studio with any luck in a moment, and I'll show you what I'm up to. All right. So what I'm hoping you can see here is Visual Studio. Can I just have a quick yay or nay on that, Esther? Can you see that? Esther may not be saying it. May not be online. I'll just quickly zip back and see if I can see if anyone can see it. Yay! Thank you. Excellent. All right. So Visual Studio here is. I've got an application started here that I want to show you. So, and the reason I got it started is because I wanted to have some sort of back-end services that we could talk about and use, rather than this start again from scratch, hello world thing. So I have a little application that has a bunch of services here, and I've just written a web API with a few little things in the controller. So I'm just going to go into my controllers method, and I have a vehicle controller. And the idea is that we have a series of vehicles that we're going to track, and those vehicles are going to have a person in them, so then the vehicles will also have a location. So let me quickly show you the classes that define that. A vehicle has a location, an ID, a driver, and the last time it was updated. The driver is a person, and the person has a nickname, a given name, a family name, and a date of birth. And the vehicle also has a location. A location simply has a latitude and longitude. And those are the things. That's a fairly straightforward model. You can imagine drawing sort of class diagrams with, which were properties and all that sorts of things. But it's, as I say, pretty straightforward. The other thing I've done here is I've defined an interface which says if you want to interact with this model, this vehicle, this model, then you need to do it through this interface, the vehicle repository interface. And the vehicle repository interface simply defines how you can go and talk to the model. It doesn't do anything other than define the interface at this stage. And the interface just says that there's a get all, there's a get of a single one, there's add a vehicle, there's delete a vehicle by ID, and an update location. And they're all asynchronous tasks. By default, it's certainly worth doing these things asynchronously. I think Edmund Wells says, "What are we, animals?" So down in our services, I'm just setting the scene a little bit here. We also have a models folder, and the model simply has a vehicle repository class, and the vehicle repository class is a concrete implementation of the iVehicle repository interface. And you can see that this has a list of vehicles as a read-only field, and then it implements a vehicle. So then in the constructor it instantiates that new list of vehicles, and then it implements all of the things in the iVehicle repository interface. It has a get all, which simply contains that list. So you can see behind the scenes, I'm not doing anything special. I'm not storing this anywhere in the database. The repository simply goes off and talks and has its stuff as a completely local set of classes. In memory set of classes. I don't even write it to the disk because this is simply a demonstration of what might happen in the background. And this is the beautiful thing about this pattern, this repository pattern, is it doesn't matter how stuff is stored anymore. I can implement this. I could just as easily have this writing stuff to a SQL server through Entity Framework. I could do it through all sorts of, I could have it as a NoSQL implementation. I could do something like write to the local file system and store all this stuff as JSON or XML files. It doesn't matter, because the interface says if you want to go and get information or put information in, use this interface and everything else is good. And then from then on, you abstracted away all that complexity. And so this is the, and I say complexity very, very cautiously, because there's no complexity to this at all. Simply it says go and get all the vehicles or a single vehicle, add a vehicle. If it's already there, remove it, then add a new one. Delete a vehicle if you can, and so on, and update the location. Very, very simple code. I'm not going to go through it in any detail. Suffice it to say that I've implemented a controller in the Web API, and I'm not going to do a whole lot about it. So Web APIs and controllers, but the Web API simply now exposes a couple of get endpoints. One endpoint with some get methods, with a post to do the to put a new vehicle in there, to update a vehicle entirely. A post to put a location, update a location, a delete, and that's pretty much it. Yeah, and it returns appropriate response codes. I'm not showing you this because it's part of the MVVM thing. I'm just saying it because there is a service behind the scenes here. It doesn't have to be a service. I've chosen to use one. The reason I've chosen to use it is because in my core project, which is this one here, I also have a vehicle repository. I also have a vehicle repository class, which uses exactly the same. Go and talk to the vehicle repository interface, the iVehicle repository interface, but it uses web services calls to go and do that. It uses HTTP, the HTTP client libraries. Now, this is a really key thing. The HTTP client libraries are awesome. They are a beautiful asynchronous way. If you haven't used the HTTP client libraries, they're a beautiful asynchronous way to go and talk to any HTTP endpoint, and they've got some lovely high-level methods. So, for example, I create this new HTTP client. I have a couple of constants. So this is the URL to my service, cross-platform location services.xealwebsites.net. I've also got the API path, which is /API/vehicle, and then I have a path for IDs if I need to go and specify which vehicle ID I'm doing. And then I can build up. I instantiate the HTTP client, and then in the constructor, I say that the all vehicles path, just combine the base URL and the API path, and the one vehicle path, just add the ID at the end. That's easy. So now if I want to go and get all my vehicles, I go and do this do-get. Now do-get's mine. I'll show you that in a sec. And I pass it the all vehicles path. That's all I have to do, and then I get JSON back, and that gives me and I use the NewtonSoft the NewtonSoft JSON.NET library, which I brought in through NuGet, to go and deserialize that JSON back into a list of vehicles and return it. Do-get is really simple. This is the lovely thing about HTTP clients. So if I hit F12, no, not that one. I love working on a Mac. If I go to definition instead, this do-get is really simple. It basically says use the HTTP client you've got and call the get string async and pass the URL. This is I don't know if you've done much HTTP client work without the. So if you've done much web service work without the HTTP client, it's completely changed my life in the way of how easy it is to do HTTP work from C#. And the beautiful thing is it's completely cross-platform. It's a portable class library that works on pretty much anything that runs C#. So it's very nicely done. It's got getString, it's got delete, it's got put as JSON. So it's got a put. In fact, the put as JSON is part of the web client API. The web API client libraries, which is on top of the JSON.NET and the HTTP client stuff. But again, this is really cool. In fact, the easiest way to show you this is I'll just quickly show you the NuGet packages in this particular particular application, this particular project. So we've got the ASP.NET, so we've got JSON.NET, we've got the HTTP client libraries, and in addition to that, we have the ASP.NET Web API 2.1 client libraries, and that actually brings in all of the others. That's the thing here that gives us footers JSON and footers XML and those sorts of things, and so on. So that's it's a beautiful, beautiful abstraction of the things that were previously quite complex. The neat thing about this is that now I can start writing some code that takes care of it. So, of course, in the repository does that, and now in this core library, I can add another NuGet package, which is MvvmCross. Now, MvvmCross I alluded to last time. MvvmCross is a MVVM framework built by a guy named Stuart Lodge and a number of others that's out in the UK. It's a really nice cross-platform implementation that provides a lot of that functionality that we talked about around I notify property change and I command, the stuff around dependency injection, and a number of other things as well, including a lovely plugin architecture that makes it very simple to create a truly cross-platform application. So I'm going to go over here and bring in MvvmCross. And I'm just going to hit the install button on the top one. Now, there's a bunch of different things in here. You can't go wrong watching Stuart Lodge's N+1 series on MvvmCross. There's hours and hours of great video and great instructions about how to do it. And you'll see him do this a lot of times, hit that install button a lot of times as part of that. But basically what's going on here is it brings in a bunch of the libraries that MvvmCross uses for things like binding and portable class support and all the other bits and pieces around the navigation and so on. Once you've done that, you end up with this additional folder here of view models. Now the view models are interesting because it comes with, by default, with a thing called a first view model and a very, very simple property. Now, there's a couple of things to point out in here. The properties are pretty neat because they're a full property found in the standard sort of way with a private field, which is initialized here in this particular case, and a public property as well that is backed by the private field. Now, getting is fairly simple. It just returns whatever the private field is. But setting is interesting because this is where we implement this I notify property change piece. And so we set the property to, sorry, set the backing field to the value that gets brought down. And then we tell the system to raise an event, raise property change, and say, I've changed this field, the hello field. Sorry, this property, the hello property. And that's what the binding engine uses to go and figure stuff out about how things should work. All right, so we're going to do away with the hello string because really what we want to display in our view model for this particular case is we want to display who the driver is, what vehicle they're driving, and what their location is, and we want to be able to put that back into the back end, onto the server. And so let's start with this. We'll I've got a whole bunch of shortcut or code snippets that I haven't come across this machine yet. I keep publishing up on Stack Overflow as well, so I might put a link to those in the follow-up as well. But here we go. We'll just so let's start off with a private string of first name, and we don't need to initialize it, and a public string of first name. And we can rename that, and I forgot to rename this, and this one. Okay, so now we have our first property. It doesn't actually get bound to anything yet. That's okay. We're all good with this so far. I'm going to make a few more of these. So let's go. Let's do last name as well. Copy and paste there, shouldn't I? Problem is I'm never that confident copying and pasting on my Mac. I don't know why. So let's do first name and last name. Maybe we'll do a license plate. So that's the vehicle we're driving. Remember I said that we don't have to store everything that's in the... So the vehicle doesn't have a concept of a license plate in here, in the model. We're actually going to use it as the ID. But and then this is and maybe we'll put a location as well. And interestingly, we can just use. We don't have to use only simple types in here. It's just as easy to do complex types or our own definition types. So this is why I didn't do copy and paste. We'll do location. Control Z. What I really want to do here is Control dot and use the models. So now it knows about location, and it's a location. And once again, location. Location. Sounds like a real estate ad. Look, that'll do for now. We can build it up a whole lot more, and I don't think I've missed anything vital in here. What we do want to do though is have a way of doing some stuff to this. We have a way of doing some stuff to this particular view model. We want to save it. We want to be able to retrieve it. We want to be able to update it, and so on. So let's do exactly that. Just give me 1 second. So the way we want to do that is we want to have a quick. We need a repository. Because that's what we're going to use to read and write data. So we can say private read-only vehicle repository vehicle repository. This is the class we defined before for our local vehicle repository, now we can use that repository to do whatever we need to do when we need to do stuff. So one of the things we want to be able to do is register our vehicle with the system. So to do that, what we really want is a command. So the way we add a command is we use the I command, and in fact, MvvmCross gives us a way of doing that with a bunch of stuff abstracted away. So instead of a private I command, what we're going to do is we're going to create an MVX command. And we're going to call this command register. And we need a public implementation of that command as well. So this is a backing variable for it. And then so we'll say public. So it's a register command, and it needs a getter and a next getter. And the getter basically says, we'll just check we've already got one. So equals unless it's null, in which case we need to make a new one. Command of, and then we're going to what you need to do when you create a new command is you need to tell it what to do when the command gets fired. So we're going to do a do register command. A do register command is a func, and we could, if we wanted to, instead of actually creating a separate method, a separate local method, we could actually just put the func in line if we wanted to with the the standard. That's syntax. We're not going to. We're going to do this, and what I'm going to do is define this type, define this method, and then I'm going to return register command. So whenever the view model gets asked for the command, what it'll do is go and check to see if it's got one. If it hasn't, it will create a new one and bind it to the do register command method, and then return. And either way, it'll return the whatever's stored in the field. Now, do register command. Go on. If I go to definition for that, we don't want to throw a not implemented exception. What we really want to do is go and build up a vehicle that we can send back to the service to register it. So we can say var vehicle equals new vehicle, and we'll just build it up with we can say location equals this dot location. We can say last updated equals date time dot etc now. We can say ID equals license plate, and we can say person driver equals new person. We'll build up this person as well. So you can see here that although we haven't exposed, although we haven't in the view model put any sort of hierarchy in, other than the location type, we haven't got a complex hierarchy of models. We've got a very flat set of properties. We're not going to store that back in the back end the same way. So the repository expects a location type and a person type as part of as properties of a vehicle. So that's okay. We can give them exactly that. And first name or family name equals family name. Oops. Did I do first name and given name? Is that really what I did? And last name. First name and last name. So family name equals last name. Given name equals first name. Nickname equals, we haven't got one, so we're just going to call it unknown. And date of birth equals null. So now we have we've built up a vehicle with all the stuff we know about in this view model. I've gone the wrong way, sorry. Just need a semicolon at the end here. And what we can do is we can call our repository and tell it to go and store this vehicle. We can make this an async command as well. Because what we want to do is we want to say await repository dot register or add, and we just pass it in the vehicle. Now the cool thing about this is, regardless of the platform, we haven't done anything platform specific at this stage. We now have a way of taking our view model and telling it to go and register a vehicle with the system. Let's show you how easy that is to do in an application. So I'm just going to build this to make sure it builds. Must work, right? It builds. So what I'm going to do now is let's add a Windows Phone. Let's add a Windows Phone project. Add project, because it's easiest to show quickly on Windows Phone with the binding, and then we'll show at least a we'll see whether it's an iOS or Android project. So we'll go new project. And Visual Studio stops for a sec. In fact, what I'm going to do is I'm going to zip back across just for a sec to see if there are questions. And we'll take that just for a moment and see if there are any questions. I've zipped across to my window so I can see if you type anything. It's making sense. Are we going to sleep? So Jan, by the way, the answer to your question is yes, it's being recorded. Good, all right, excellent. We'll zip back over here. So I'm going to create a new store app. And we're going to create a Windows Phone app, and we're going to create a blank Windows Phone Silverlight app. And this is called cross-platform location. And it's the phone one. So click OK. Beautiful. Windows Phone 8, that's great. So what I'm going to do now is it's creating this Windows Phone project. And the first thing I want to do with the Windows Phone project is name page.xaml, because I'm going to use the MvvmCross way of doing these things. It actually is going to create me another XAML. It's going to look a lot like this, but it's going to have a few additional things. So I'm going to delete the main page.xaml. Delete that there. Yes, he said. Excellent. And what I'm going to now add some references. So the first reference I'm going to add is a reference to the core project, because I need it to get access to the view models and to the models and so on. So that's okay. I'll do that. And the next thing I'm going to do is manage my NuGet packages. And I'm going to add MvvmCross, and it's going to do exactly the same way as we saw before. I'm just going to install that. Now the nice thing about NuGet, of course, is it knows that it's being added to a particular project type and adds a whole bunch of references that are relevant only type. So if we close this, what you'll see is in the Windows Phone project, we have serious.crosscore, but we also have serious.crosscore.windows Phone, so it's the Windows Phone implementation of things. Whereas in the core project, we only have serious.crosscore, serious.mvvmCross, and obviously no platform-specific implementations. This is the nice thing about MvvmCross and the nice thing about NuGet. So what we've got to do a couple of little things when we create a MvvmCross Windows Phone project, and those things are very conveniently told to us here in this to-do list. So I'm going to remember to do those things in the app.xaml.cs in the constructor. I need to do some setup. In the constructor here. And then I also need to I need to override the application launching. So instead of the Windows Phone default navigation system working, the MvvmCross navigation system will work for us. .xaml.cs, and so instead of application launching doing nothing, it actually would do a bunch of stuff. So it's when we launch it, we hook into the navigating system, and that all happens down here, the cross-core resolve. So now, interestingly, here's a great example of dependency injection. Resolve method here says, go and find me the thing that's been registered as the imvx app start object. Whatever that happens to be, go and do that, and I know it's going to have a start method because that's what the interface says, and go and start it up. So it makes it really simple to put different implementations of the interface into the system. So I'm not going to delve deeply into that, but there's a good example of the unmeeting dependency injection. So what we've got now is we have I'm going to close up XAML. Yes. Save those. And I don't need that text file anymore. What we have now is we have a views folder, which has got added by that NuGet package as well. And you'll notice in the views folder here, we have a first view.xaml. Now this is very carefully named first view, because you'll notice we also have a first view model. And by convention, MvvmCross uses the first view model, or binds the first view model to the first view's data context when you start it up. Now that is a convention. You can override it, but that's the easy way to do it. So let's see what this view looks like. It's MvvmCross view, and it looks exactly like what you'd expect your Windows Phone page to look. Now, there's a couple of interesting things. One is it's an MVX phone page rather than a phone application page, which is MVX phone page inherits from phone application page, but it has some additional functionality, which means that it handles some of these other things around navigation, so on, and data mining quite easily. It extracts away a lot of that stuff. So what we're going to do is let's just bind some stuff to it. So what we might quickly do is I'm going to hide the Solution Explorer for a minute. I've got more space. So instead of calling this My Application, let's call it Tracker. Yeah, and with an R, not a C, not a ER, because we're kind of calling it nitty. And we'll call this text Me. This is all about me. And then on this page, we have a stack panel with a text box, which is the text. So let's have a look at the way this binding works. So we have a text box on this page, which is this one here, and it has text in it, and the text is bound to a property called hello, and that hello comes from whatever the data context is for this particular page, or in fact, it could be the page, or it could be the grid, or it could be the stack panel. Each of those can have data context, but they inherit back up the stack. And in this particular case, the data context for this page is what everything's being bound to. Now, we don't have a hello in first view model, so let's get rid of that, and we'll call that first name. We don't necessarily want a text block that displays it again. So we'll delete that. But we want first name and last name. And I can just bind. This is easy here, so I go last name, and I'll show you what this looks like in a sec. So that's neat. So we had first name and last name. What else did we have in our view model? The view model had license plate, location, and a register command. Okay, so let's just quickly put a rectangle in here. Oops, a line, in fact. Height equals 2. Foreground, no fill. And we'll use a static resource. I don't have to be a static resource, but we're going to, and we're going to use the foreground brush. Now, what that says is basically draw me a rectangle, height 2, width all the way across, and fill it with whatever the foreground brush is for this particular phone. Now, the nice thing about that is if we change from a dark theme to a light theme, then everything will get inverted, and it happens automatically. You don't specify in particular. That's just a Windows Phone technique. Then we want another text block. Let's do it on the. Yep. We want the license plate. And maybe another rectangle. And then, now here's the nice thing about binding. We can say I want the location, dot latitude, and I want the location dot longitude. So this is a really neat thing about binding in XAML, and most of you will know about this stuff. It's pretty cool, but I love pointing it out. And the last thing we want to do is a button, which has got content of register, and it's bound to, the command it runs is bound to the view model as well. Because remember, we have a command in the view model. and the binding is register command. So now we have I could put all sorts of hints about what should be in each of those text boxes, but we know it's first name, last name, license plate, location, latitude, longitude, and the register button. So, well, without any further ado, let's run this up and see what happens. Hopefully, it's going to. Well, let's build it first, just to make sure I at least haven't made any stupid syntax errors. Excellent. So let's deploy it, and I've got an emulator running. So we'll run it up. We'll say debug start new instance. That deploys it. And here we are. So let's say Andrew Coates. License plate AAA111, latitude minus 33.25, longitude 152.34. Now, before I hit register, I want to go across to Fiddler here. I want to show you what happens when I go and hit my service. So at the moment my service says go and get me all the vehicles. So I'm going to execute that. It will return some JSON. It does return some JSON. And JSON it returns is empty. Yeah, nothing at all. Awesome. So this is sitting on the back end. Let me show you the URL again. It's out somewhere on the internet, cross-platform location services.azure website.net/API/vehicle. But when I go into here now and hit register, we're going to make a call out to there as well. And now if I go and execute this, I get some JSON back, and this time the JSON should be, there it is. So now I've got back all that stuff's been pushed up to the internet. That to me is pretty cool. It didn't take a lot of code to go off and do a whole bunch of really interesting bindings to send stuff up there. That's pretty neat, I reckon. I haven't implemented the update stuff or any of the delete things, but again, you can see how easy that would be to do in a command and so on. What I do want to do now is to go back and get into and show you that in at least one other platform and show you how easy that is to do. So I'll go back to Visual Studio, and we'll stop that one, and go to Solution Explorer, and minimize the phone one. I'm going to quickly zip back and ask you, do you want iOS or Android? Type it in the window. Someone wants iOS. Jan wants Android. Toby wants iOS. iOS. Okay, looks like iOS is winning. Oh, it's 3-2. Okay. So, okay, we'll do iOS this time. Maybe we'll do Android next time. It really is very simple. In fact, I'm quite glad in the way we're going to do iOS, because iOS is a little bit different in that it has a different binding syntax in the current implementation, although there's some things changing about that. But I should just be able to go here if the Xamarin gods are with me. And right-click on cross-platform project. I want to add a new project. We're going to add an iOS project. We'll do it for iPhone. We can do it for the Hello World application. Doesn't matter. What's it called? It's called cross-platform location. And this is going to be .touch. Excellent. Okay. There we go. Continue. What it's got to do here, so Xamarin needs a build host on a Mac machine somewhere. There should be one running over here, actually. It's not. I'm surprised. Ah, that's why, because it's not actually running. Maybe it is running. It is running. On. What I'm going to do is go and restart it over here. Compare. Q. Here's someone quit. Restart. Thing, parents. Copy that to the clipboard. So this is more of a thing that Apple insist on, in that they insist every iOS developer has a Mac essentially, and so I'm going to reload. Oh, okay. So let's go tools, Xamarin. Just a bunch of mine. Okay, continue. That one. Connect. It's going to ask me for the pairing code. Paste here. Finish. Okay. So now I have in my Solution Explorer, I'll just pin it again so I can see what's going on here. I'll make it a little bit wider. And then touch. Down the bottom here we have, this is the stuff that happens by default with our, without adding any MvvmCross pieces. So if I ran this up, it would run a simple Hello World project. I'm not going to do that. I'm going to right-click on here, and we're going to manage some, add some references. Sorry, references. I'm going to add some references. And the first reference I need to add, obviously, is my core project, so I can get access to my view models and so on. Okay. And then I'm also going to manage NuGet packages, and I'm just going to bring MvvmCross in. And what that does is, again, it goes and installs the common libraries and also the platform-specific libraries for iOS. It also gives me a to-do. One of the things I have to do is, this is a bit strange, I don't know why this doesn't just work. If I go to appdelegate.cs, I'm going to copy all of this and override this appdelegate.cs. And that's a bit of magic that does things behind the scenes, and you can investigate what that does. It's actually not that difficult, but it's kind of nice that it does. And then other things I need to do in the Touch UI, that's all done. Lots of this stuff actually happens now automatically, and a few of these things haven't been updated. A few of the to-dos haven't been updated in a few versions of MvvmCross, but you learn pretty quickly what bits have already been done, which haven't. And then in views, once again, we have a first view. And the cool thing about first view is that it's and we're going to bind fields to it. So the interesting thing here is you can go in and build a UI with Xcode and then bind stuff to it. And in fact, in the new version of Xamarin, which has only come out in the last day or so, last week or so, 3 or 4 days, whatever it is, there is a UI designer which I have yet to play with, so I'm not going to try and show it to you today. But what I do want to show you is how we might build up exactly the same setup as we had before. Now we're going to go a little bit over time. My apologies. We want some labels. In fact, we don't want labels. We want text fields. We're going to get rid of that label. We don't need to bind the label either, so I'll get rid of that. But the text fields are going to be bound to first name. We should have an IntelliSense here because it knows about what view model it's bound to. We're going to bind to a text field 2. Now, because we're doing all this layout manually, we're going to field 2 to last name. Rectangles, but let's do, what do we have? We had license plate and 2 location fields. And the license plate is going to start at 130, and then lat field and long field. Oops. Yeah, that's right. And I know this looks cumbersome, but in fact, you get used to doing it pretty quickly. 130, giving adding 40, 170, 210. And then I'm going to make sure we bind license plate, location dot latitude. So in some ways this binding is nice because it's got all the IntelliSense. We don't want that one. That last one doesn't exist. And we're binding it to textual 1, textual 2. This is LP field. This is lat field. And this is long field. All right, so now we have all of our text boxes set up. It happen automatically. I also need to reg button equals new UI button. And the UI button takes a UI button type. And round rectangle is good. Yep, and we can say reg button dot I think it's frame equals new rectangle F, and let's do this. Could be the same as these. And instead of 250, maybe 270. Do that. And then reg button, we need to set it to text. Set title, I think it is. Yep. And set title, we're going to set it to register. And then the last thing we need to do is, oops, the wrong way, set.bind, bind, and we're going to bind the reg button dot for, and it's a reg, it's the VM dot. So was it the register command? I'll put one button. Oh no, it's on. For iOS, it's something slightly different. It's on. Now it's up. Touch up inside is what it is. And we're binding it to the VM dot register command. Oops. Love my new keyboard. Okay. So now we've bound the command as well. So hopefully what we should be able to get now, why is that giving me an error? Maybe it's just one of these. Something sort of here. let's just try this. I have a feeling this may be incorrect, and if it is, then I'm going to apologise and fix it in there and for the code I put up. But let's just build this and see what happens. I said title register right down here. Okay. Come on. Dot. Okay. So let's do a build now. Two errors. What are my errors? Okay, yes, I'll do that in a sec. Yes, all right, I'll fix that in a moment as well. All right. Now what I'm going to do, I'm going to out of that. What I might do is I'll just show it running with hopefully with just the binding in an iOS thing. But I do need couple more things I need to do. The properties here. In the application, I need to give it some details. That's actually all been done for me. Beautiful. And then I need to say I am going to make this the startup project. That way I can say I want to deploy to the simulator. And the simulator I want to deploy to is the iPhone Retina. That'll do. Hopefully, I should just hit start. See, crossing his fingers, holding his breath. It's our iPhone simulator starting up. Good sign. Even better sign. And I might just play this big. Change the view. Something wrong. So I'll take it back here and have a look and see what it is. Should be a bunch of my Apple window should show me what's going on. View output on the Mac server log. It's fine. The build log. That was okay. The deploy worked. Debugging. Nothing much here going on. All right, guys, I'm going to. I'm not going to try and debug this in front of you on the webcast. It's never a lot of fun, and it is 8 minutes past already. But what I will promise to do is fix that code up and post it with a link on the Lallinger site. Where you saw the registration for this, and we'll get that going as well. Rest assured, it does work exactly the same way, and I'll prove it to you, and maybe even post a video. That might be a cool thing to do. So what I'm going to do now is duck back to the presentation. Yeah, absolutely, Toby. There's no Objective-C going on. Isn't that an awesome thing? Yes, Jan, Xamarin's a great start, but you still need to buy a Mac. I agree. You're right. I should have chosen Android. It would have been a whole bunch easier. Yes, Stephen, your question about Android development. You can just use a PC. You don't need a Mac at all. Clement, I don't know about the MVM. I mean, I know about the MvvmCross. Sorry, the Xamarin Form stuff. I haven't had enough time to think about where MvvmCross fits into that. Toby, it needs to connect to a Mac compile because you can't compile for iOS except on OS X. That's just the way it is. That's Apple decided that. To be fair, though, you can't really compile for Windows on anything except the Windows box. So it's not necessarily unreasonable. I guess it's got a whole bunch of dependencies it takes, and they don't want to devolve those dependencies to anybody else. Why does it need to connect to a single Mac is another interesting question, though. There's nothing technically saying you couldn't build with a single Mac for a bunch of different developers. That's a limitation set by Apple to say that they must have a Mac per developer. I guess it's a simple way to make sure that their numbers go up. So, John, that's true. Xamarin Forms does look like it's going to let you create UI generically for all platforms. With MvvmCross, you might need to create a UI layer for each. Now, the interesting thing is going to be what's the next evolution of that. I'm fascinated to see how MvvmCross is going to adjust to this the Xamarin Forms stuff. As I say, it's so early that I haven't really had a chance to play with it yet. I'm really looking forward to doing that, and once I've finished this next round of travel that I'm doing, I'm expecting to spend a lot more time on it. But you're right that there are pluses and minuses to both approaches. I think the nice thing about the Xamarin UI stuff, Xamarin Form stuff that I've seen so far is it really does still use native controls under the hood, which is pretty neat. Let me quickly get back to slides while we're talking. And I want to quickly recap some of the things we looked at. Notify property change makes it really easy to bind. Command makes it easy to do stuff in the view model based on stuff that happens in the view. Dependency injections allows you to define an interface and then implement an interface per platform or per requirement, regardless of the actual concrete implementation. You can still call the interface and commands. We do dependent code. Particularly, I talked about the cool stuff in HTTP client, being able to go and call web services with that. We haven't talked a lot about platform-specific code and navigation. In fact, I'm going to put that off till next month. Next month, I'm also going to do some stuff on mapping, which is a really great platform-specific thing that you can implement in still using a cross-platform approach. So I'm looking forward to doing that as well. Once again, I'd love some feedback. So in the Windows, great. If you've got things that you want to tell me personally, then ping me on email. If you've got things you want to tell the world about me, then pop it on Twitter. Yes, I know it'd be great not to have to wait for a whole month, Jan, but I'm afraid I'm going to be away for 2 weeks and then I have to prepare the next presentation as well. So that's true. I would love some feedback about this session in particular as well. So if you wouldn't mind popping up to aka.ms/codecfeedback, or you can just snap that QR code and give me a little bit of feedback. It's only for 5 or 6 questions, and none of them is obligatory. But the more feedback I get, the better. The more I can tell my boss that this is worth doing, the better. I love doing these presentations, and it's to me it seems like a good use of my time. But having some external validation of that, or otherwise, is a useful thing as well. So I'm just ducking back through the code here at all. Oh, sorry, the chat window to see if I've missed anything. So Jan asks, yes, Toby, I'll definitely spend some more time on the different OSs, not much more time on the MVVM stuff next time. I did feel I needed to set that platform. But you're right. Yeah, we need to build some stuff for all of the OSs, and we'll do that next time as well. And particularly if we're going to do mapping, which is what I want to do, we'll do that. Now I'm just so Jan, you were asking on early on. You said Windows. It's all been done and covered. I'm just, as I say, I'm going through the chat window. So Stephen, you asked, is there a way to have a Mac running in a virtual machine? There's not, as far as I know, and John's answered that as well. No legal way to do that. You do need a Mac, but a Mac Mini is not all that expensive, and it runs it quite nicely. That's what I run at home. I've got a MacBook Pro here, so I can run it all on one box when I'm presenting. But at home, I have a Mac Mini which runs just in the corner, and that's all it does. Yeah, John, you've already said that. That's great. It doesn't really encourage Windows developers to write for iOS. Well, I think so. Jan, you said that you said doesn't encourage Windows developers. So one of the interesting things I think is that the Mac thing is neither here nor there, but it's getting much easier for Windows developers to write for iOS with things like the Xamarin Forms and also the Xamarin iOS UI Designer, which has come out in Xamarin 3. Excellent. All right. I think that's just got it all covered, folks. Thanks very much for your time. I do look forward to seeing you all next month. I think Esther will put the details up on Lala Ninja again when that's ready to go. I expect it'll be about the same time next month, so sort of early in July, and we'll publicise it through Lala Ninja and through the Windows Phone newsletter. Look forward to seeing you all later on, and hope you have a wonderful June. Enjoy the balmy winter weather. Cheers.